Welcome to this video tutorial of IoT-based carbon monoxide and carbon dioxide monitoring using Arduino and MQ2 and MQ135 gas sensor modules. The design would be assembled and programmed to read alarming rates of these two gases and notify the people around it of such readings. It will also export the values to a Thingspeak IoT dashboard, where it can be further analyzed by an expert. First we begin with the schematic diagram. The schematic diagram of the power supply is shown here. It is a basic switch mode power supply, SMPS. It uses 220 to 240 VAC input and gives 5 volts 5A output. The components are to be connected as shown above. Alternatively, one can opt for the use of an already made power supply that can supply 5 volts, up to 2A of current rating. The microcontroller circuit diagram is next shown. It is built around the Arduino Pro mini board. The MQ2 gas sensor module was connected to the analog pin 1 of the Arduino Pro mini board, while the MQ135 was connected to analog pin 2. The power rails for these gas sensor modules were connected to the 5 volts and ground pins accordingly. A buzzer is added to the design for alert beep. We used the LM7805 to denote the supply of 5 volts to the circuitry. It is wise to note that the ESP01 takes 3.3 volts and you will need to power this from the 3.3 volts regulator on board the Arduino board. The OLED module is connected using a 2C protocol and 5 volts from the power rails. We use 2 LEDs as visual alert indicators. When the green LED blinks, and it denotes the air quality is good, when the air quality is bad for breathing, the red LED blinks. Now, let us move on to the assembling and casing of the project design. We assembled the components on a variboard and soldered them accordingly as shown in the circuit diagram. The casing of the components was done using a 3x6 inch polyethylene box. It was wrapped aesthetically in holes made for connectors and switch. The sensors were placed at points where it can better sense the air around the device. For programming the Arduino Pro mini board, we made an opening to ensure we can connect our FTDI programming cable even when the design casing was close. This will allow us to make modifications to the program, test it out and ensure it is working as we intend it to be. Once this is done, we move on to setting up the Thingspeak IoT dashboard. This is where we can see and monitor the readings of the design remotely. Once signed in, we click on Add New Channel, and this will open up a page where we can fill in the details of the channel. The name of the channel, the details and the number of fields needed for the project are the most important things. After this, we head over to API keys and copy off the right key. We will need this in the program source code. After a bit of cleaning up on the dashboard, we can end up with something that looks like this. Just 2 fields to show the device parameters and a location to show where the device is installed. We can now talk about the Arduino sketch or source code for this project design. To see the Arduino source code for the project video, kindly visit the blog post link in the description link below. It is free and it is well explained. Let us begin testing the project design. The project is first powered on by flipping the switch at the top of the casing. It is turned on and displays the welcome message and also the title of the project design on the LCD. We have replaced the OLED module here with an LCD, but the communication protocol is still the same. Kindly check for a copy of this code in the description link. We can see the measured CO and CO2 levels displayed on the LCD. These levels are good, hence the blue LED is turned on. And when we connect the device to the internet, we can see the measured values that are displayed on the Thingspeak IoT dashboard. The readings keep updating every second. Thank you for watching. Kindly leave us a comment below if you have question. See you again on the next video.